Hi, it's me Kritika, Assistant Professor, Department of Chemistry, K.S.Rangasamy College of Technology. Today, we are going to see the topic of potentiometric sensors. What is the overview? We are going to see about definition, working principle, key components, what are the types of potentiometric sensors, applications of potentiometric sensors, advantages and disadvantages of potentiometric sensor. Then we move on to definition. So what is that? What is a potentiometric sensor? It is an electrochemical device that measures electrical potential, that is a voltage between two electrodes. What are the two electrodes we are using over here is a working electrode and a reference electrode without drawing a current. This potential which forms over here, no, this potential difference reflects the concentration of specific ion or analyte. So what is the solution we are taking in this beaker or in any container? We call that one as a analyte. That is, we are going to find out the concentration of a specific ion by using the potentiometric sensor. See here, the reference electrode was given and a biosensor or a sensor which is used to detect the that is difference between the electrodes, that is electrical potential, that is voltage. So both the electrodes are connected to an potentiometer. Okay, let me move on to the working principle. Based on the Nernst equation, which relates electrode potential to a constant to ion concentration, the working electrode responds to the analyte. So by using the Nernst equation, we are finding out the ion concentration. So the working electrode responds to the analyte. So analyte is the solution, no? Then while the reference electrode maintains the constant potential. So see here, this is a reference electrode. This maintains the constant potential. So see here, the sensor outputs a voltage signal which is directly proportional to the analyte's activity. So always the voltage is directly proportional to the this analyte activity of this solution. So see here, this is a reference electrode. This is the ion selective electrode, or we call it as a reference, that is an internal electrode. So this is the internal solution. We call this membrane as an ion selective membrane. So what are the key components? That is working electrode, sensitive to the target ion. What is a reference electrode? It provides stable baseline potential. So what is an electrolyte? It facilitates the ion exchange. Either it may H plus or Fe2 plus or Fe3 plus, any other. The potentiometer, this is a potentiometer instrument which is used to measure the potential, that is voltage difference. What are the types of potentiometric sensors? There are many types of potentiometric sensors are there. Here we are going to see just only 4 potentiometric sensors. First one is ion selective electrode, ISE. That is example glass pH electrode. We are going to see this in detail. So ion selective field effect transistors, screen printed electrodes, solid state sensors. Then we are going to see about glass pH electrode, that we call as a ion selective electrode. So it shows that it will that is check only the ion selective, some ions only, selectively it will identify the ions. So a glass pH electrode is a type of ion selective electrode. It responds to which ion? H plus ion, that we called as a hydrogen ions in a solution. So it consists of a thin glass membrane. So what is a thin, very thin glass membrane? This is the very thin glass membrane. It will interact with the sample. What is the solution we are taking now? That's this one. So this one interacts with the sample and generates a voltage signal which is proportional to pH level. Okay, see here the glass tube which has a thin walled membrane, that is pH glass membrane. Here that we called this one as, this is permeable porous junction over here, that is Ag, that is silver chloride reference electrode. This solution which is filled was KCl solution, and silver chloride reference electrode, it is an act as an internal electrode. Let we see on this, that is a glass bulb which is sensitive to hydrogen ions, made up of special pH sensitive glass. Internal reference electrode, which is usually silver and silver chloride. This one AgCl. What is the internal solution? Typically a buffer one, that is which is known pH. Here we are taking a KCl solution. So what is the outer reference electrode which completes the circuit with sample? So what is the body which is a protective casting for the holding together? So all this everything was holded in a body, that is a protective casing, that is which everything it holds together. Okay, so what is the ion exchange? So that is H plus ions from the sample interacts with outer surface of the glass membrane. What is the potential difference? A voltage develops across the membrane due to what? That is difference in H plus ion. This is very important. What is the potential difference? That is, it is due to difference in H plus ion concentration. Where it takes place? Between internal solution and the sample. Okay, then what we are measuring? This voltage is measured against the reference electrode and converted into a pH value using the Nernst equation. So this is the basic equation. We are going to find out the value. So what are the advantages, limitations of glass electrode? Here particularly we are seeing only about glass electrode. So advantages: high sensitivity to H plus ions, reliable, accurate readings can be get, and widely avoidable one, that is standardized one, suitable for a broad range of solutions. So what is the limitation of this glass electrode? It is fragile. Fragile means that is the glass bulb can easily break. Requires regular calibration. See, we have to calibrate the experiment, that is experiment in sometimes. So regularly we have to calibrate it. That is a limitation for this. It is sensitive to temperature changes. Not ideal for very alkaline or non-aqueous solutions. Then we see about the applications. pH meters for lab and field use, glucose monitoring in medical diagnostics, environmental monitoring, industrial process control, agricultural soil analysis. Then we see about the advantages and disadvantages of potentiometric sensor. So particularly here we are saying about, that is commonly we are saying about potentiometric sensor. What are the advantages? Low power consumption and high accuracy, cost effective, easy to install, resistant to corrosion, chemical interference, suitable for harsh environments. So what is the disadvantage? That is, it is sensitive to electrical noise and temperature changes. Requires careful calibration. This we also seen in pH electrode, no, same thing. Limited pH range for some electrodes, fragile and prone to surface damage. Thank you.